Now let's talk of kinematic graphs. Let's start with position versus time plots. Now these, what they do is give us the location or the position at any time. Remember, displacement is change in position. The graph is not going to give you a displacement, it's going to give you a position. The slope in this graph is going to give us the velocity. Okay, let's try to explain. Sometimes you might see in books or on the internet this axis labeled as D and them speaking of distance. That's wrong. Usually we graph just position. Most of the graphs that are labeled with D are position graphs. Just be careful with that. So we have the vertical axis is position, the horizontal axis is time. What we see here are the positions at different times. In this particular case, it's telling us that whatever is moving here started at position equals 0. It moved away from it towards the positive direction till it reached a position of about 4 meters, and then it went back till about the position of 1 meter, and then moved forward again till reaching about 2.5 meters, probably a little more, and then went back to the 1 meter position here. That's what this graph is telling us, what happened to the position. Now, at any point, if I would like to find the velocity at this point, I get the slope of the graph at that point. The slope of the graph would give us the velocity. In this case, we have a negative slope. So that tells us that whatever object is moving backwards here. That's why we have a negative slope, negative velocity. So the velocity, if my positive x is pointing this direction, my velocity is going to be pointing this direction. Thus the negative slope. Now if I'm here, see, my slope is a positive slope telling us that the object is moving in the positive direction with a positive velocity. If we go to the top here, slope is 0. That's when we have a 0 velocity. That's essentially when our object is going to turn around, so there is a momentary stop. That's what we have there. Now, let's answer the questions here. What is the position at t equals 3 seconds? So we check the graph, 1, 2, 3, here. So the position, and then we check here. So that looks like it's about 1 meter. If our graph was labeled properly, it would tell us here it's in meters. Then it's asking here, what is the displacement between t equals 5 seconds and t equals 1? Okay, so let's erase a little bit here. So we have a clean graph. Go back to pen mode. So our position at 1 second is here. So x at at 1 second is 2 meters. And then at 5 seconds, this is 5 seconds, the position is 1 meter. X at 5 seconds is 1 meter. So my displacement between both positions is x5 minus x1. So that's going to be 1 meter minus 2 meters. So that's going to be minus 1 meter. So I have a negative displacement, minus 1 meter, telling me between these 2 seconds the overall displacement is in the negative direction and with a magnitude of 1 meter. Then the next question is asking about the velocities at these various times. Okay, let's go back and try to focus on them. Velocity at 1 second, so we are here. So I need to get the slope here. Remember, slope is rise over run. So for example, if I get this line, the run is 1 second, the rise is 1, 2. So it's 2 over 1. So for this here, velocity at 1 second, it is 2 meters per second. At 2 seconds, so this is my 2 seconds here. So I get the slope. So that's my line. Okay, so let it extend. So this looks like it's another notch here. So we are 1, 2, 3, 4, 5. So our rise is -5 and our run 3. So my velocity at 2 seconds is going to be -5 meters over 3 seconds. So it's -5/3 meters per second. And then velocity at 3 seconds at 3 seconds we are here. So that's my line. So it's a horizontal line. My slope is 0. So velocity at 3 seconds is 0. The next question is velocity at 4 seconds. So I'm going to erase this one. Four seconds is here. So I again have to do rise over run. I'm doing it approximately here with a tiny graph. So we are going for a run of from here to here, that's 2.5, and a rise of about 2.5 as well. So my velocity at 4 seconds, 2.5 over 2.5 is 1 meter per second, plus 1 meter per second. So you notice here we have a steeper slope, so we had a higher velocity, lesser slope, so a lower velocity. Okay. Lots of questions in one screen. Now the next question is asking us to find the average velocity between t equal 5 seconds and t equal 1. Remember, the average velocity is displacement over time. The displacement, we calculated it here. So it's minus 1 meter over the time, 5 minus 1, that's 4 seconds. So it's minus 1/4 meter per second.